My talk is going to be an introductory talk as well. I'm going to give you an overview of some emerging and priority pollutants. I'm not going to spend a lot of time on each of the pollutants or class of chemicals. I'll just touch it shortly because I think you will encounter some of them in more detail throughout the week. So let me introduce myself first. My name is Helga Stopper. I'm a professor for toxicology at the Department of Pharmacology and Toxicology at the University of Würzburg, which is in Germany. So planetary health. The health of our planet is in danger, really. And why is that important? Because a non-healthy planet can be a danger for us in the future. It can compromise the well-being of humans in the future. They have defined some boundaries for planetary health, and you can see here the red areas are areas where we have already damaged the boundaries. That means that maybe the changes are non-reversible in the future. What does that have to do with toxicology and with pollutants? Well, some of the damages that are done are due to us putting chemicals in the environment. For example, it includes the burden of environment with endocrine disruptors. Endocrine disruptors are substances that disrupt the hormonal balance. Also, we have polluted our planet with small particles such as fine dust, nanomaterials, and microplastics. Then there's e-waste, which is the waste due to electrical and electronic appliances. And there's, for example, drug residues in the environment, and there are many more things that we've put into the environment, but I'll focus a bit on these ones. Now, new concepts have come up. For example, the One Health approach, where a lot of authorities recognized that we cannot just look at the toxic effects on humans if we want to judge a chemical or the potential problems with a chemical. We also have to see the interdependence of humans, animals, plants, and the ecosystem. Now let's start with endocrine disruptors. So these are chemicals that somehow are able to disrupt the function of hormones in us humans, and they can be harmful to our health by disturbing growth and development, by influencing reproduction in a negative manner, by increasing the susceptibility to specific diseases, or they may have carcinogenic effects, for example, as tumor promoters, so they may support the growth of a tumor. This is an older example from 1992, where Carlson already reported that the sperm count and the quality of sperm, of human sperms that is, has declined between 1983 and 1990. Some newer studies have also supported these findings, maybe not to such a large extent as this one, but in principle, the sperm quality is decreasing. If it were the extent that this one shows, then if you would extrapolate this line, then you would see that at about 2035, humans would have no active sperm anymore, and we could not reproduce anymore. That's, I think, not the case, but the basic fact that the quality and number of sperms is going down is true. And also already Carlson et al. Have attributed this to environmental pollution. They said that something in the environment must cause it. Now, there are a lot of possible things in the environment that could cause it, but last year, 2 papers came out blaming PFAS. So this is just an example of 2 papers. The left one says toxic effects of per and polyfluoroalkyl substances, which are PFAS, on sperm, and the right one also says association between PFAS and semen quality. So what are PFAS? PFAS is an abbreviation for per and polyfluorinated chemicals. And there are more than 10,000 of these chemicals, of this type of chemicals. PFAS do not occur naturally, so we have put them in the environment. They have only been produced since the late 1940s. These are all appliances and items where you can find PFAS in. So PFAS are pretty much everywhere. Why is that? Because they have such good features, good in the sense of usable features, like they are water, grease, and dirt repellent, and they're chemically and thermally stable. So they are processed in numerous consumer products, such as cosmetics, cookware, paper coatings, and textiles. They're also used for surface treatments of metals and plastics, and they are part of pesticides, and they are put into fire extinguishing agents. And they can be introduced in our food. We can take them up via food and drinking water. And how can that be? Well, that is because they can be detected in soil, they can be detected in drinking water, they can be detected in animal feed, and in consumer goods, for examples, in food packaging. And from the food packaging, the PFAS may leak out into our food. So they can be absorbed by us. Here you see the chemical structure of two examples of these compounds, two of the more famous examples of this class of compounds, PFOA on the left and PFOS on the right side. Back to endocrine disruptors in general. How long have endocrine disruptors been known? Well, they have been known since there has been a large amount of industrial waste in the environment. So that means after the 1950s. And the first identification of compounds as endocrine disruptors were usually due to chemical accidents, so large pollutions in a local area somewhere. And this is one example where very early on endocrine disruptors have been described. This book is called Silent Spring. It's by Rachel Carson, a biologist, and it was published in 1962. This book is really often considered the starting point of the global environmental movement, and it's really one of the most influential books of the 20th century. And what it's about? It's called Silent Spring because Rachel Carson observed in the spring, where she then wrote the book, that there were no songbirds around. The spring was silent because no birds were singing. And she said this must be due to the environmental pollution. At the time, no one believed her, but it turned out later that she was right with most of the things that she said in the book. And for a mechanism for the missing songbirds, it turned out that it's similar to what happened to the bald eagles on the Great Lakes in the USA. For a while, they were reduced to a large amount because there was a contamination of the Great Lakes with DDT, which was used as a pesticide, a compound that's now banned, but it was used to a large extent as a pesticide. And it contaminated the fish in the Great Lakes, and the bald eagles ate the fish. And because of the DDT, they could not produce good eggshells. The calcium signaling for the signaling pathways for depositing the calcium in the eggshells was disturbed. Therefore, the eggs were not good enough to be to yield young bald eagles. And the problem with the songbirds was a similar one. Of course, they don't eat the fish, but they eat insects, and they were also poisoned with DDT. Another two examples that I want to mention is, the first one is alligators in the Lake Apopka in Florida. There was a chemical accident polluting the lake with DDT and also with the metabolites of DDT, and that is back in the 1980s. And it was found that the male alligators had smaller penises, which really worried scientists a lot. And there was more estrogen found and less testosterone in their blood. And then another example is in the 1980s and 90s, female sea snails in Europe, Asia, and in USA showed penile growth and were sterile. And it turned out that the compound tributyltin, TBT, which is contained in paints on ships to prevent the growth of things of muscles and stuff which attaches to ships, and to prevent that, you need something mixed in with the paints, and they use tributyltin a lot. It was identified as a problem, and its use was severely restricted since then. Another example are dioxins, an example for endocrine disruptors. Dioxins were never produced on a technical scale, so they were never produced intentionally as a compound that you want to use. Instead, they can occur during combustion processes in the presence of chlorine and organic carbon. So they are created as a contaminant if you produce other products that you want, and if chlorine is used there during the chemical process. Dioxins used to come through into the air via waste incineration plants, but that has now been drastically reduced because they have set limit values and they have better technology. But there was an accident with dioxins. That's a long way back, but we've learned a lot from that accident. And this is the so-called Seveso accident. Seveso is a small city in Italy. And the dioxin in question there was the most dangerous one, which is tetrachlorobenzodioxin, TCDD. And in 1976, in a factory, some tanks with chemicals exploded, and a lot of this TCDD was released into the environment. There were thousands of dead animals around the area. But luckily, there was no death in humans. No death could be really firmly connected to the accident, but there were other problems. Hundreds of people were affected by chloracne, and this picture here shows a child affected by chloracne. Chloracne can sometimes not only cover the face, but the whole body. It is very difficult to treat, and it's very painful. So this happened as a result of the TCDD burden, and people were afraid that it would cause an increase in cancer incidence, but it did not. The overall cancer incidence was not increased in the environment, in the area there, but there was a shift in the tumor types. But most strikingly, the sex ratio at birth shifted. And this was a hormonal effect. When you look at the table here, then you find that in families that were affected to a large extent, where the TCGD blood levels were very high, there were no male births in the time between 1977 and 1984, so the time of observation of a particular study. After the accident, there were no male births, no boys were born, but 12 girls. In the families that were burdened much less, this was not the case. There were 4 boys born, 1 girl. And if you look at an overall number, now the estimate is that the ratio was about half of what it usually is. Usually have the roughly equal number of boys and girls being born, and there was a largely reduced number of boys born. So I just want to give you some further examples of endocrine disruptors without explaining them in detail. Some pesticides can be endocrine disruptors. Then we've heard about tributyltin. Bisphenol A is a monomer of polycarbonate plastics, which is also a very well-known endocrine disruptor. Phthalates are plasticizers in plastic. That means they are substances that you have to add to make the plastics flexible. Then there are surfactants, such as nonylphenol, and then there are flame retardants, such as the polybrominated diphenyl ethers, that you have to add to many consumer goods so that they are not inflamed, that they don't catch fire so easily. And there are many more compounds now that are known or suspected as endocrine disruptors. Moving on to the next topic, the next category of substances that pollutes our environment: fine dust and microplastics. So in 2023, it was a very warm and dry spring in many parts of Canada. And you might remember that last year there were thousands of fires, and it was the worst wildfire season in the country's history. The fires could not be extinguished at all. There were fires for many months, and 230,000 people had to leave their homes at least for some time. And the smoke reached, for example, also New York. The right picture here shows New York, and this is not fog or anything. This is the smoke from the Canadian wildfires that reached New York in such an extent that people had to wear masks there for protection from the smoke for a while. The smoke also reached Europe. In Europe, we saw it as particularly nice red sunsets. Whenever you have a very nice red sunset, you can be suspicious that there's some air pollution going on. Now in 2024, because it was warm and dry in the spring, forest fires have already started. So wildfires are a reason for particles in the air. But not just wildfires, also many people in developing countries still cook with open fires, and often indoors. So they are exposed a lot to the smoke from the fires. For example, here in the left picture you have a woman cooking in Ethiopia, and in the right picture it is in India, a woman cooking here, and you can already see this particularly affects women who do the cooking, sometimes in the house with no good air circulation, and also the children who are a lot around their mothers and a lot in the house also. So the WHO estimates that this results in around 4 million premature deaths every year. And of course, particularly in poor countries. So what's so bad about the fires? The combustion processes produce many pollutants, such as soot, fine dust, and gases, which go into the atmosphere, and they're of course taken up by inhalation. And you may also have organic compounds in there, such as carcinogenic polycyclic aromatic hydrocarbons. You have carbon monoxide, etc., etc. And if the particles are very small, then they can penetrate very deeply into the lungs. And if they are very, very small, the smallest particles can also enter the bloodstream and thus reach all the organs. So you can have a local irritation of the respiratory tract, but you can also end up with diseases such as an increased plaque formation in the blood vessels, and even stroke or heart attack are possible consequences. And particulate matter is now one of the top 10 risks for premature death. Microplastic in the ocean. You've all heard about this, but let's have a quick look at what this means. Every year, 4.8 to 12.7 million tons of plastic end up in the ocean. And it takes hundreds to thousands of years for it to completely decompose. But the current in the ocean, the friction processes, create smaller particles from the large plastics. Below 5 millimeters in size, then these are called microplastics. And these microplastic particles are a huge problem in the sea. Well, one reason is because animals may take them as, or they may misinterpret them as food and eat them. For those animals that usually eat plankton, they might eat the small particles. And also the small particles are not easy to get out of the ocean again. With the ocean cleaning efforts that are now done, you cannot get the small particles out. You can only get the large pieces out. This is some history of the discovery of plastic in the ocean. And I think it's quite interesting to see that even in 1972, researchers from Woods Hole Institute in the USA, they wanted to investigate some nuclear power plants, the effects of them on some coastal ecosystems, and they found plastic particles in their nets that they used to catch the samples. They were very surprised at the time to find plastic in the ocean. And then also 1973, some other researchers found plastic 600 miles away from civilization, where they were really, really surprised at the time to find plastic bottles and a coffee pot and an old balloon. In 1997, there was another guy, and he drove back from Hawaii on a regatta, and he drove through what's now called the Pacific Garbage Patch. So it was an area where there was a large concentration of many floating plastic objects. That was the first discovery of that. And in 2004, the name microplastics was created first. And the biologist Richard Thompson pointed out that we have no idea how these microplastic particles behave in the environment, and whether, for example, they can enter the food chain. And in October 2018, Austrian scientists discovered microplastics in human stool samples for the first time. So the proof that we do take up these microplastics, that they're now meanwhile everywhere, is just only a few years old, really. The left picture shows this great Pacific garbage patch, which is like an island of garbage, of plastic garbage. And it meanwhile has the size 3 times of France. There are 5 such garbage patches in the ocean, and they are formed because of these streams in the ocean, these gyres that where the plastic waste is centralized, is localized into certain areas. And it looks like an island, but of course it's not a solid island. It's just an accumulation of waste that goes deep down from the surface and is visible on the surface. So are microplastics now toxic for us humans or not? The Federal Office for Risk Assessment in Germany assumes that microplastics do not endanger health. They think, or they think that we have proof that the human body excretes the microplastic particles again without being harmed. This is true for a size of plastic particles between 1 and 5 millimeters. However, for smaller particles, 1 to 1,000 nanometers, it is not known right now whether in what quantities we can take it up. We also have to consider that even if the particles are taken up and the particles as such don't seem to harm us, but plastic can contain plasticizers and other questionable components, which we might then take up from the plastic particles. And also it's interesting to know that some organic substances tend to accumulate on the surface of microplastics. For example, some long-lasting, hardly degradable environmental toxins, for example, DDT, which I mentioned earlier, the now banned pesticide that had been used a lot, but has been banned for some time, but it's around everywhere on our planet. And in 2015, University Hamburg scientists found that microplastics contains 3 to 4 times as many toxins as the seabed next to them. So they really accumulate, they attract the toxins. And Chinese researchers now found in microplastics even in clouds in last year. And they think that the microplastics in the clouds might in turn affect our weather by making the clouds maybe darker and causing maybe more rain. And they are just not natural clouds, so they're different in how they react with the sunlight. Moving to the next topic, which is e-waste. So hundreds of thousands of tons of used electrical and electronic devices are delivered to African countries every year. This is not legal. Legally, we can only transport used appliances that could be rebuilt, that could be repaired. But really, approximately 75% of these devices do end up as electronic waste and are not repaired because it's not possible to repair them, because it was clear from the beginning that this is really waste. Germany is really one of the world's main suppliers with a 20% share of this. And the problem is that workers, and they're often children, they extract materials from this e-waste using very primitive methods, as you can see in the right picture. So they have no protection and they're exposed to whatever compounds come out of this material by trying to extract useful metals, for example, from the material. And so a child who eats just one egg from a chicken from one of these e-waste sites in Ghana will consume 220 times the EU daily limit for chlorinated dioxins. So we see how poisonous this can be. And really only 17% of the e-waste ends up in good standard recycling plants, which also exist, and they offer more protection to the environment. But the vast majority is deposited illegally, and the poor people there try to get some materials out that they can sell and are affected, and the workers are affected, and it's not even yet known how the families are affected, live close by, because a lot of the damaging material also leaks into the ground and might affect the water there and might affect the soil there where they grow their vegetables. And that's not even known yet. So more than 1,000 pollutants can be released, including, of course, many metals like lead, mercury, nickel, but also brominated flame retardants and polycyclic aromatic hydrocarbons. For example, the cables, when they set them on fire to get the metal inside, then of course the plastic is burned and releases some of these dangerous compounds. So health consequences include, of course, impaired lung function, but also thyroid function and increased risk of some chronic diseases, even cancer and cardiovascular disease. Now moving on to a next exposure, which is drug residues in the environment. The pharmaceutical production of pharmaceuticals production, we produce a lot of veterinary pharmaceuticals and human pharmaceuticals. And as you can see in this picture here, there are various pathways how they get into water. For example, the veterinary pharmaceuticals, they're given to livestock to prevent disease, and then the manure comes, it's put on the fields, and it ends up in the groundwater. And human medications, of course, in the household or in hospitals, also ends up in the wastewater, cannot be cleared out by wastewater treatment plants. So a lot of these drugs end up in the fresh water, and this becomes an increasing problem, really. We have to consider that drugs are optimized for stability during development. So they're not easily destroyed because they're supposed to stay stable to exert their function. And we know that we have around 2,500 active ingredients, for example, in Germany. And we estimate that about 4,000 active pharmaceutical ingredients are administered worldwide, either to humans in prescription medicines or over-the-counter therapeutic drugs or veterinary drugs. And it's estimated that about half of them are environmentally relevant. And I would like to give you one example of how the environment can be affected. And this is, again, a historical example, but I think quite interesting. And this is about diclofenac and the vulture population in India, Pakistan, and Nepal, which was at risk. So in these countries, the vulture population was reduced to almost no birds left, to 1 to 3% within a 10-year time frame. This was back in the 1990s. Initially, a virus was suspected at the cause, but then it was found out that they died from kidney failure. And diclofenac was identified as the main problem. Diclofenac at the time was used in veterinary medicine in these countries, especially in cattle. You have to remember that in India, cows cannot be slaughtered, they're holy, they cannot be killed. So they are very old. Cows in India are very old. And then they get arthritis and they need medication, and they're given diclofenac. So there were a lot of cows around which were very old and had a lot of diclofenac in them. And then they died eventually. And at least in the 1990s, these cows died, they were just lying around there. And the vultures ate the meat from these dead cows and got a lot of diclofenac. And birds seem to be very sensitive to that. So they died from kidney failure. But it got even worse. When the vultures disappeared, dogs that lived in India ate the dead bodies of the cows, and they multiplied massively because now they had, well, lots of food, and they didn't die so easily from it. And this led to the spread of rabies in humans again, or humans were endangered by the spread of rabies to the dogs. So this really shows how a problem that we caused by putting too much diclofenac, in this case, into, well, the animals, and then it ends up in the environment as feed for other animals, how this comes back to us, endangering human health. Now, once the cause was identified, there was a ban for diclofenac in this type of use. There were breeding projects for the vultures, and the vulture population has slowly recovered. Diclofenac, the demand in the world is huge. In 2018, there was 2,000 tons of diclofenac used around the world. Diclofenac is, as you might know, especially used against pain in the musculoskeletal system. And there are oral drugs, of course, but there are also ointments and gels that you apply locally. In Germany, for example, the consumption is around 85 tons per year. The diclofenac that's orally administered or injected forms metabolites and is predominantly excreted in the urine. But the diclofenac that you apply locally is not really taken up very well, and this is often a large disappointment to people who are very active in sports, and they like to use these diclofenac applications whenever something hurts. But it really doesn't work very well because only 5% of the substance is taken up. 95% of the substance remains unchanged on the skin, and it's washed off when you take the next shower. And of course, by taking the next shower and washing it off, it goes into the wastewater, and it's not eliminated by wastewater cleaning, so it ends up in the environment. Okay, another example for an exposure with medications, and this is an experiment. They used a small enclosed lake in Canada in 2007. This was published in 2007. They used this small lake in Canada, and they wanted to find out what it does to the environment if estrogens are induced into such a lake. And they introduced estrogens in the same concentrations that you can find in some areas across the world, and estrogens, of course, used in oral contraceptives, and through elimination via urine, they end up in the water and in the environment. So after the first summer, the male fish produced vitellogenin for egg production. So the male fish produced this protein that is used for egg production. And a year later, the sperm production in the male fish was really restricted, and instead the male fish produced eggs. But the entire fish population could not really reproduce any longer. And even 2 years later, this is how long the observation was done, without any further estrogen inputs, the fish population had not recovered. Moving to another aspect of medication in the environment, the global burden of antimicrobial resistance. This is an analysis from 2022, and it says that in 2019, there were almost 5 million deaths from diseases in which antimicrobial resistance plays a role. This is human deaths across the world. 1.72 million deaths were a direct result of resistance. So drug-resistant infections killed more people than HIV or AIDS or malaria. In Europe alone, more than 30,000 people die every year as a result of antibiotic resistance. And we have to keep in mind that most antibiotics are not used to treat sick people. Most of them are used in animal husbandry. More than 70% of the antibiotics worldwide are used for that purpose. For example, in 2020, around 700 tons of antibiotics were used for animals in Germany alone. Resistant bacteria have now even been found on vegetables, and that is because the exhaust from the air stables and also the manure that's put out in the fields are a reason for transporting these resistant bacteria out. And slightly different disposal of medication. We have touched this a little bit with the diclofenac already, but this is a general issue now. As we take more and more medications, population, the number of people is more, and we have more old people, so we have more medications. And all medications are often disposed incorrectly by patients. For example, we tend to throw liquid medication in the sink or the toilet. And that means it ends up directly in the water. Again, the wastewater, the way wastewaters are prepared right now does not eliminate the medications really. So Recommendations for safe disposal vary between countries. What you should throw in the normal trash, whether there's specific trash for it, whether they have collections or special places that you can take them to, or whether you can take them back into the pharmacy. There may be certain return options. So I would encourage you to please check the recommendations in your country and ask your pharmacist what to do with old medications that you don't need anymore. Just don't throw them away and don't put them down the sink if they're liquids. Okay, a little bit about climate change and the consequences of climate change for our health. We all know that there's global warming, and if we look at it, there has always been a normal, natural variation in the weather, but us humans have caused an additional increase. Well, can we not adapt? Why is it dangerous for us? Well, the human body can adapt to the heat. You sweat more and with a thinner sweat, but this adaptation has limits, and it's not enough to keep up with the climate change. With no wind and with sunshine, with 50% humidity, the body cooling is overwhelmed at around 43 degrees. This is what you can take without immediate damage. In dry air, it is about 54 degrees. It is now estimated that about 30% of the world's population is exposed to a potentially deadly combination of heat and humidity, at least for 20 days a year. And it's estimated that this could rise to 50% of the population in 2100, according to forecasts. Now, the problem is, if this is in an area where you have air conditioning, you can just stay in the house and cool down. But if this is in poorer areas where you don't have any air conditioning, no way to protect yourself during work, then this can be a real danger for your health, for your life. So there are more and more zones around the world in which people cannot live without these technical aids like air conditioning. And also we might want to remember that medicines can have different effects in hot weather, for example, because you don't have the same amount of thirst. It changes the thirst, and then you don't drink enough due to the medication, and so on. I want to show you a few examples of what things can get more dangerous due to the climate change. For example, in warmer surface water, the increase of bacteria, the growth of bacteria increases, and there are some toxin-producing bacteria. For example, the toxic blue-green algae. In German, we call them blue algae, but they're neither blue nor algae. They're really green, and they are bacteria. They're cyanobacteria. And direct skin contact with them causes irritation. They produce toxins. If you swallow them, if you go into a lake that has these bacteria, if you swallow them, there might be nausea and vomiting. But also, if you swallow a lot or over a long time, there might be liver damage and nerve damage, really, as a long-term consequence. And the rising temperatures, of course, promote the growth in this. And this is in lakes and also in seawater, in the ocean, that these algae grow. Then there are jellyfish. This is the example of the Portuguese galley, which is normally found in the Pacific and Caribbean, but it has now also been observed in the Canary Islands and Portugal, and some beaches had to be closed because of this. Now, this is not the most dangerous jellyfish in the world. It's already more dangerous than what we used to have in Middle Europe. If you encounter it, it's very painful, but it's not life-threatening to a healthy adult, but a not-so-healthy person or a child might really be in danger. And why have they moved to Middle Europe? Well, because they like warm and dirty water, so nutritious water for them. And it's maybe interesting to know that jellyfish kill around 100 people every year, and usually we can consider sharks so dangerous, but sharks only kill about 10 people per year. Mycotoxins is also something I briefly want to mention. Mycotoxins can be carcinogenic, and mycotoxin-producing molds, they grow depending on the temperature. And so far in Middle Europe, we didn't have the most dangerous species of mycotoxin-producing molds. For example, aflatoxins we didn't have any bacteria, any molds that produced aflatoxins. But the temperature increase changes that. And This is an estimation, so this is not a true finding, this is a model, an estimation of what could happen. The left picture shows the distribution of aflatoxin contamination in maize. And the left picture shows what we have now. And you can see that in Germany and also Belgium, we have no aflatoxin contamination. If we have aflatoxin in the food, it is imported with the food to us. It's not formed by any, it's not formed here, so it's imported. But the middle picture shows the climate scenarios with 2 degrees increase. And you can see that we have a little bit coming up here of aflatoxin, but this picture with the 5% increase shows that pretty much most of Middle Europe, we will have a huge problem with mycotoxins. And in general, the use of pesticides is expected to increase because food plants are more difficult to protect when there is more heat and dryness, or alternating rain and dryness as we have had it now. So the use of pesticides is expected to increase worldwide, and that happens now where we finally are about to recognize that it's not so great to use a lot of pesticides on your crop, but worldwide it may still increase in the future. And also pesticide use may have to be increased because we see a spread of infectious diseases. We see mosquitoes which transfer diseases that were not known before in Europe, in Middle Europe at least. For example, the tiger mosquito, the one shown here in the picture, used to be absent, but has now been found. These red dots already show populations of tiger mosquitoes in Germany, and this is from 2020. They have since increased, so we now have tiger mosquitoes. We have not seen the transfer of dengue, West Nile fever, etc., from the tiger mosquitoes in Germany, but where they originate from, this is exactly what they do. They transfer these diseases, and these diseases are in some of the affected people can be deadly. In most of them, they're relatively harmless, but there's a subpopulation where they are really a threat to the life. Okay, I want to finish with this slide, and this introduces the concept of the Earth Overshoot Day. That is the day that determines, on that day, humanity has used up all the resources that would be available for the entire year. And so it's established for each country. So if we look, for example, on Germany here with the red arrow, then May 2nd was the day in 2024 where if all the world population lived like the people in Germany, the resources would be exhausted for the entire year. And I think you can see the other European countries up here, and I found Belgium, March 23rd. So Belgium is even sooner than Germany in this. And one final slide shows how we could change this, move the date. How can we influence the Earth Overshoot Day? We could reduce CO2 emission. That would give us an estimated 93 days. We could improve industrial processes. The energy generation would give us 21 days. And we could reduce global meat consumption. If we only reduce it by 50%, that gives us 17 days. If we reduce food waste, 13 days. If we plant trees, 8 days. And if we use public transportation or the bike or we walk, we can also add 13 days to that. So we have some things that we can do to move the date. And with this, I would like to close and thank you very much for your attention.